Good day, students. Welcome to mathgoodserve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the Algebra 2 New York Regents Common Core exam for January 2017. Alright, let's take a look at question number 11. Question 11 reads, the solution to the equation 18x squared minus 24x plus 87 equals 0 is... Now, what we have here is a quadratic equation. Okay, we know it's a quadratic equation because the highest degree of this polynomial is 2. Now, there are different ways you can solve a quadratic equation, but if you take a look at the options, it can give you an idea as to the right approach to use. Now, if you take a look at the options, we have imaginary solutions. Anytime you have imaginary solutions as the only set of options in a question, that tells you that you cannot factor. Okay, it's a prime scenario, so you have to make use of either completing the square or its condensed version known as the quadratic formula. Okay, so the formula we're going to use here is the quadratic formula. Alright, let's go ahead and write down what it is. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Alright, so let's write down our quadratic equation. 18x squared minus 24x plus 87 equals 0. Now, anytime you're solving a quadratic equation, it's always beneficial to ask yourself, is it reducible? Can I express the equation in a simpler form? So 18 and 24, those numbers are numbers that 3 can go into. How about 87? Can 3 go into 87? If you add the digits and the sum is divisible by 3, then you know that the number is divisible by 3 also. Okay, so 8 plus 7 is 15. And 15 is divisible by 3, hence 87 is divisible by 3. Okay? So what does that mean? It means that we can reduce this quadratic equation by dividing every single term by 3. So what does that give us? It gives us a simpler equation to work with. 6x squared minus 8x plus 3 goes into 8 twice. That's 6 carry 2. 3 goes into 27 9 times. Okay, so this is a simpler quadratic equation that we're going to be solving using the quadratic formula. Okay, so now we need to determine what A, B, and C are. So make sure that your quadratic is written in standard form before you determine your A, B, and C values. Okay, so it's already in standard form because each term, the terms are arranged in descending order of degrees, so it's already in standard form. So let's figure out what A, B, and C are. There you have it. Okay, so when you're using the quadratic formula, if any of the terms A, B, or C are negative, please use a parenthesis. Okay, so help you avoid making sign errors. Alright, so we have negative b, so we have negative parenthesis negative 8. So let's say I didn't use the parenthesis. Some students might forget that we have two negatives here and they will invert their sign. Okay, so always use parentheses anytime you're inputting a negative input value. Plus or minus b squared negative 8 squared minus 4ac all over 2a. Okay, all over 2a is 2 times 6. Now, let's simplify. Multiply minus times minus, that gives us 8 plus or minus square root. So I didn't put my square here. Square root of negative 8 squared. Since the negative is in the parentheses, it's square 2, which gives us positive 16. And then we can multiply these two. So let's go ahead and bring out our calculators to help us out. Well, actually, to save time, we can just enter the entire expression. Okay, so we're going to do parenthesis negative 8 raised to the second power minus 4 times 6 times 29. Okay, and we get negative 632. Alright, so let's enter that instead. So our radicand is negative 632. Since we have a negative radicand, that tells us we will have imaginary roots. Okay, so that divided by 2a. 2 times 6 is 12. Now, how do we reduce this radical right here? It's always beneficial to look at your options and have it guide your problem solving process. If you take a look at the 4 options, they all have 158 as the radicand. So what does that tell us? It gives us a hint that there's a strong possibility that 158 goes into negative 632 by a complete squared factor. Okay, so let's go ahead and verify that hypothesis with our calculator. So we're going to divide 632 by this number that keeps showing up in the radicand divided by 158. And the answer is 4. So excellent. That works nicely. All right, so what do we have? This becomes 8 plus or minus. Now we have a minus here, so we have to take care of that. Okay, so what's the square root of negative? The square root of negative comes out as an I root 4 root 158. Okay, so just remember that if you have a square root of negative, that negativity comes out as an I. Okay, all right, so what do we have here? This entire thing divided by 12. Okay, now we can split it apart. So we have the real part and the imaginary part. So we have 8 divided by 12 plus or minus the square root of 4 is 2. 2i over 12 root 158. Okay, so let's go ahead and simplify by dividing by the GCF. In the case of 8 over 2, the GCF is 4, so divide by 4 top and bottom. And that gives us 2 over 3 plus or minus. Now if you take a look at 2 and over 12, the GCF is 2, so divide by 2 top and bottom, and you get I over 6, or you can write it as 1I over 6 times 1 root 158. Okay, so there goes the answer to our quadratic equation. The correct answer is option number 4. Okay, 2/3 plus or minus 16i rad 158. Alright, let's take a look at question 12. It says, when g of x equals 2 over x plus 2 and h of x equals log of x plus 1 plus 3 are graphed on the same set of axes, which coordinate best approximates their point of intersection? Okay, so let's go ahead and graph these two curves using our graphing calculator. So the first one is 2. Now this is very important. There are 2 terms in the denominator, the sum of 2 terms. So in order to accurately enter this into the calculator, we need to use parentheses. Okay, so parentheses x plus 2 groups these 2 terms together in the denominator in the calculator. Okay, so you have to know how to accurately enter expressions into your calculator in order to get the correct result. Okay, and then the second function is log. We have log right here of x plus 1 plus 3. Enter. Alright, so we're going to graph the 2 functions. So what we're looking for is the point of intersection between these 2 functions right here. Okay, this is a logarithmic function that has been shifted, and this is a rational function that has been shifted too. The point of intersection is somewhere right there. So to calculate it, we're going to use second function calculate, option 5. As for the first curve, which is a rational, press enter. The second curve, the logarithmic, press enter. It says guess, so just move your cursor to an area that's close to the point of intersection. Press enter, and there you have your result. Okay, so I've grabbed a screenshot of the calculator just to help you zoom in on the relevant component. So that point right there, that's the intersection point that we're looking for. Okay, and then the ordered pair that corresponds to that point is, so the intersection is negative 0.92692, comma 1.86379. I'll just leave it like that. Okay. All right. So if we round it up to one decimal, well, let's see. You round it to one decimal place. That's what's done in the options here. So if we round it to one decimal place, we're going to have negative 0.9, comma 1.9. Okay. So this is the value of the intersection, and we can clearly see our answer is option number 2. All right, let's take a look at question 13. It says the price of postage stamp and the years since the end of World War I is shown in the scatter plot below. So we have a scatter plot here. Question: the equation that best models the price in cents of a postage stamp based on this data is, so we have 4 functions. We have a linear function, 2 exponential functions, 1 with an obvious faster growing rate than this one, and then we have a trigonometric function here. So which best represent this scenario right here? Okay, so if we just think about it for a second, we can eliminate options. Okay, a linear function is a straight line, and this clearly is not linear, so we can eliminate that. And a sine function oscillates, it exhibits an oscillating type behavior. We do not see any oscillations here, so we know for certainty that this is incorrect. So it's either option 2 or option 3. Okay, so what we're going to do is we're going to go ahead and enter all the functions in our calculator, and then we'll see what the correct answer is. Okay, all right, so let's start with the first one. We're going to do it in order. Okay, so the first one is 0.59x minus 14.82. That was the first one. The second one is 1.04 times 1.43 raised to the x power. The third one is like it's switched around, 1.43 times 1.04 raised to the x power. And then the last one is our trig function, 24 sine 14x plus 25. Okay, so let's graph the functions and see which one best approximates what we have. Okay, okay, so it looks like some functions are missing. It's really hard to really compare what we have to this scenario right here. So how can we be able to make a better conclusion with the graphing calculator? What we have to do is we have to adjust the window to match the parameters of the given window. Okay, so we're going to press the window button, and then we'll adjust our x and y window. Okay, so from x, we're going from 0 to 100. So the minimum x is 0, the maximum x is 100. Enter. And then for our range, what's the span of the y? Y goes from negative 10 all the way to 60. Okay, so we're altering our window to match this window exactly so we can make a better conclusion. There goes the first one, the linear function. The second one, the exponential function with rapid growth. Third one coming up. There you go. Is also an exponential function with a significantly slower growth rate. And there goes your trig function oscillating all over the place. So we can clearly see that option 3 is the correct answer. Okay, so let me go back here. I'll just select 1, 2, and 4, so you can focus your attention on the correct graph, which is the slower growing exponential function. Alright, so based on this graph, we can clearly see that our answer is option number 3. Alright, let's take a look at question 14. It says the 8th and 10th terms of a sequence are 64 and 100. If the sequence is either arithmetic or geometric, the 9th term cannot be, so notice here, cannot be. Okay, so this is a arithmetic and geometric mean problem. Okay, so let's distinguish between both of them first before we set up our problem. So recall, arithmetic sequences grow by what? Grow by a common difference. D. Okay? So in the case of arithmetic sequence, you have repeated addition. Okay? Alright, so you add the same thing over and over again to generate subsequent terms of an arithmetic sequence. On the flip side, geometric sequences do what? They grow by a common ratio. Okay? And that common ratio is called R. In the case of a geometric sequence, what you have is repeated multiplication. When you multiply over and over again, you generate the terms of a geometric sequence. Okay, so with these definitions in mind, let's go ahead and set up our arithmetic and geometric mean. Start with arithmetic mean. So our arithmetic mean is basically a sequence, an arithmetic sequence given where only the first and last terms are presented, but the intermediate terms are missing. Okay, so we have a sequence that goes on dot dot dot, and then you have the 8th term 64, comma, the 9th term is unknown, and the 10th term is 100. So this is what a geometric arithmetic mean looks like. Okay, so to generate terms for an arithmetic sequence, what you do is you add the same number over and over again. So in this case, from the 8th term to the 9th term, we're going to add the common difference D. We don't know what it is. From the 9th to the 10th, we're going to add a common difference D again. So what is that D value? This setup can help us to generate a solvable equation. This setup tells us that starting from 64, if you add 2 D's, D plus D, you will end up with the 10th term of 100. Now let's solve this. Subtract 64 from both sides. You have 2D equals 36. And then divide both sides by 2. And you get your D value, which is 18. Okay? Alright, so with this D value, we can determine what the 9th term is. So this follows that A9 is going to be A8 plus the common difference. Okay? A8, the 8th term is 64 plus the common difference of 18. If you find the sum, your answer is going to be 82. Okay? So the missing term here is 82. So if we have 82 there, we're going to eliminate it. So let's take the 82 out of there. Alright, now let's advance to the geometric mean scenario. Okay? So for the geometric mean, what do we have? So for geometric mean, we have a geometric sequence going dot 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 dot. You have an 8th term of 64, a ninth term that's unknown and a 10th term that's 100, just like the arithmetic mean up there. In the scenario of a geometric mean, what you have is repeated multiplication by the common ratio r. Okay? Now, this setup can also enable us to generate a solvable quadratic equation. So we have the 8th term 64 plus what? Nope, not plus, times what? Times, because remember we are multiplying repeatedly, right? Times 2r's, which is going to be times r squared, is going to give us the 10th term, which is 100. Okay, if you multiply by 1r, you get the 9th term. We don't know what that is. Multiply again by r, you get 100. Alright, let's solve this. First things first, let's divide by 64 to isolate the variable. So that leaves us with r squared equals, this is reducible, let's see, by 4. So we'll basically divide numerator and denominator by the GCF, which is 4, and we have r squared equals 25 over 16. To get r isolated, we use the inverse of the square function, which is the square root. So root the left and the right, like that. Now, anytime you take the square root of a square, you have to introduce plus or minus. Okay, so we have plus or minus 5 over 4. So what this tells us is that there are going to be two possible answers for a9. So a9, the 9th term, is going to be generated by taking the 8th term and multiplying it by the common ratio r. Okay? So for r equals 5 over 4, the positive one, the 9th term is going to be 64 times 5 over 4. Okay? 4 goes here 1, 4 goes here 16. 16 times 5 is 80. So possible answer here is 80. Okay? But another acceptable common ratio value is the opposite of 5 over 4, negative 5 over 4. Let's see what we get. When we input that into our equation here, so a8 64 times negative 5 over 4 is just the same as the other one, right? But we just have the negative sign in there. Okay, when we reduce this, 4 goes here 1, 4 goes here 16, you times it out, you have negative 80 as another possible answer. So it could be 80 or negative 80. Those are two viable responses. So it cannot be 80 or its opposite. So our final answer is option number 1. Okay, let's take a look at problem number 15. It reads, the loudness of sound is measured in units called decibels. These units are measured by first assigning an intensity I sub 0 to a very soft sound that is called a threshold sound. The sound to be measured is assigned an intensity I, and the decibel rating D of the sound is found using the equation D equals 10 log the ratio of the quotient of I and I sub 0. The threshold sound audible to the average person is 1.0 times 10 to the negative 12 watts per meter square. Consider the following sound level classification. So we have 4 sound level classifications here. So the question is, how would a sound with intensity 6.3 times 10 to the negative 3 watts per square meter be classified? Okay, so we already have the formula provided for us. So let's rewrite the formula for determining the sound level classification of a particular sound intensity. So the formula is classification D is equal to 10 log base 10 of I divided by I sub 0. Okay? Alright, so let's see what we have and what we need. I is the sound intensity that you're trying to classify. So in this case, it's going to be 6.3 times 10 to the negative 3. I sub 0, on the other hand, is called the threshold sound. Okay, that's humans can hear. So that's I sub 0 is 1.0 times 10 to the negative 12. Okay, so threshold sound has this value right here, and up, if you go up, you're told that I sub 0 is the threshold sound. Alright, now what is D? That's what we're looking for. Okay, that's the decibel value that will help us classify this particular sound intensity, 6.3 times 10 to the negative 3. Alright, so to find D, we'll just input these values into our formula. 10 equals log of 6.3 times 10 to the negative 3 divided by 1.0 times 10 to the negative 12. Okay, so let's have our calculator do the work here. So we have 10 log. Now in the numerator we have multiple things going on, so I'll group it in parentheses. Okay, so you can write 6. You can write this as 6 times 10 to the negative 3, or you can use the E option. So I'm going to use the E option. 6E 10 negative 3. This is just a short way to say times 10 to the, okay, and then here divided by parentheses. Okay, quick correction here. If I'm making times 10, the E is good enough, so I'm just going to have E is times 10 to the, and then we have 1.0 times 10 to the negative 12. The short form using a calculator is just E and then negative 12. Okay, just like that. Close the denominator. Close the logarithmic argument. Enter. Your answer is 97.781. Okay, now if you don't want to use the E, you can just use 10 to the negative 3. It's still going to give you the same answer. Okay, so our D value is 97.7815. If we round it to the nearest whole number, is going to be approximately 98 decibels. Now, what is the sound classification of this decibel level of sound intensity? So it's going to be, where is 98? 98 falls right here. So it should be classified as very loud. Our answer for number 15 is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial, or any algebra question on the Regents exam in general, just place your questions in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool math tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day. Goodbye.